Hello, everyone. Uh, Today, we are going to do a demo. Essentially, in this demo, we are going to use BigQuery to do our analysis. Idea here is to analyze two different public data set, run some queries on them separately, and then have them combined and do some kind of query to see interesting insights that we can derive from the combined data set. So let's get started. First and foremost, we need to open BigQuery interface. So we need to go to Big Data section, Big Data, BigQuery, and you can also pin it up here. So when you pin it up here, it would show in your pin location. So you can go ahead and click on BigQuery. What you see here is a query editor. It gives an interface for your BigQuery. You have like a bunch of different section here. Saved query is a good one. Let's say you have ran a bunch of different queries in the past. You can always go on to saved query. It would have a list of all the queries that you have run. You can directly pull one from here and then you can do your further processing. You have job history, which would have historical data about your job performance. Schedule queries. Let's say you have some queries which you want to run maybe in a timely cron job fashion, then you can have them scheduled here. So essentially you write your query here and you just click on schedule query. You have your BI engine. Let's say if you want to do some business intelligence kind of reports, you can click on that and you can have your information there. So first thing first, we need to add data to our BigQuery. You click on add data tab here, click on explore public data set. As you see here, you have this bunch of different data available here. You go ahead and you select New York bike. Data. Let's say if you click enter, you'll find New York bike information. So you see here city bike information. Click on that. Give it a few minutes. It's trying to load the data. You can just go ahead and click here and then try to refresh here. Your data will be loaded in your GCP console. Give me 1 second. Looks like we are having some kind of technical issue here. NYC bike, click here. You don't need to create this. Yeah, we need to add a project ID. I think that part was missing. So forget this thing. Okay, anyways, we have our data here. So let's try and get some information. So if you go to city, NYC city bike, if you go here, NYC city bike, city bike trips. You have all this information here. Now you can go ahead and run this query. Now, if you see here, this data is valid. It is going to pull 3.3 GB when run. So let's go and let's try to run the data and see how we are pulling the information. So now if you see here, the query completed in 10.3 seconds. It processed 3.3 GB data. If you look at execution, overall the time that this query would be taking is 7 minutes and 58 seconds approximately. It did shuffle of 1.65 GB, but because of its distributed nature and parallel processing, you see here it is taking only 10.3 seconds. So if you let me, you see these are the input parameters repartition that the compute is taking some time and write is taking less amount of time, but compute is where it's trying to pull all the data, do some kind of computation on the data. You see here that a lot of repartitioning process and sorting is happening behind the scene. Now let's try to run this data and see. Now the idea is let's find a query to see how much total distance is traveled by each bicycle in this data set. But before that, let us quickly look at the data that we had. So you see here, it is pulling start station name and station name, typical duration, and number of trips. Now we are interested in how much time it is taking, like each trip, how much time they are taking. So you have this. Now you see here, this query will process 1.2 GB of data when run. So you run this data. Okay, so it gives you your bike ID and it gives you total distance which is traveled by the bike. So you have, these are like 5 different bike IDs and you're getting this different information for that. If you want to look at the job data, you can see here that it is processing 1.19 GB of data. If you want to look at number of records, you can go here and see how much time it is taking to pull this information. This is the JSON response of the data that we have got. And this is the job execution information that we have. To get more clarity, we can always show and hide our editor here. You can look at the result, you can play around with the data here. If you also want, you can also explore this data in Data Studio. Data Studio is nothing but it's a visualization platform like Tableau, where you can slice and dice your data and get different kind of reporting out of it. Now let's look at weather data. Let's look at another data set and see if we are. Look at 2015 data, 2015. You see, these are the field. You have like ID type, your date, element, value, all this information. Let's show our editor and then try to replace query. Essentially, what we are trying to do here with this query, we are trying to find out the amount of rainfall for all days in 2015 from a specific weather station in New York. ID of which we are providing in our query. This specific is for Central Tower. If you look here, this will return 1.1 GB of data when it is run. You run the data. So you have like the amount of rainfall for each day in 2015. So it starts with January, February, it goes all the way till April, because after April, we are not having rain for 2015. Now, the idea is you have this rainfall data, you have this ride cycle data, you have these two different data sets. How can you find correlation between these two data sets? So that's where we'll compose our third query to get this information. Clear your query interface. You have your another query here. Again, this will pull 1.5 GB. Green symbol here, it shows that your query validation is good. You go ahead, you try to run the query. See, what you're seeing here is it gives you a ratio out of some 50,000 trips, 19,500 trips were on a rainy day, and approximately 29,000 trips were on a non-rainy day. So that's the end-to-end correlation that we are trying to build here. So essentially in this lab, what we did was we created two ad hoc queries for two different data sets. We were able to pull the data set into our BigQuery interface. We were able to create indexes on those queries. We analyze two different data sets to find different interesting insights from those data sets. At the same time, we are able to correlate between these two data sets without leaving our BigQuery interface. And we were able to derive insights saying that, hey, out of 50,000 approximately bike rides, we had 20,000 rides which were on a rainy day, and approximately 29,000 rides we had on a non-rainy day. So the idea here is BigQuery makes it very easy to analyze large-scale data. Few of the key features that BigQuery provides is that you would have to, in a traditional data warehousing system, you would have to run the query and see what are the kind of performance issues and not. But here, it would tell you upfront like what amount of data it would be pulling. And because beneath the scene, it leverages distributed architecture, even though query processing time would be like, let's say 20 hours, but because you have many multiple worker nodes working on this query and the data is partitioned across the cluster, you are getting result back in less than a minute or within few seconds, 10, 15, or 20 seconds. So that's the beauty of BigQuery. And again, you can have your cloud IAM capabilities integrated into your BigQuery, so you can assign different kind of roles for a specific user who wants to work on those kind of reports, or whom you want as a business user to give access to. So with that, thank you for your time. And if you have any questions, I'll be more than happy to answer them. Thank you.